Hello friends, welcome to engineering tutorial. So we'll continue our discussion on thermodynamics. In this video we are going to discuss about the concept of change of state of a substance. So first, what is change of state? Now we all know that every substance, object, it exists either in one of the three states: solid, liquid, and gas or vapor state. And any of these three states, it can be interchanged, one state into another. And we can do it by either heating it or cooling it. So this transition of a substance from one state to another, that is called as change of state. Now there are various terms associated with it. So some common change of states, as we all know: solid to liquid through heating, that is melting of a solid; liquid into vapor through heating, that is called as vaporization; then liquid to solid through cooling, that is heat is taken away, so that is called as freezing; and vapor into liquid through cooling, that is called as condensation. So these are some common change of states. Now here we are trying to study, our main objective is to study the curve, the graph of change of state, and we'll take the example of a simple experiment of melting of ice. The change of the transition of states of ice from solid ice to liquid, that is liquid water, into vapor, that is water vapor. We will study it with the help of a simple experiment. So we'll start the experiment by taking some ice cubes in a beaker, and we will heat it on a constant heat source. And another thing which we have to do is we have to take the readings of the temperature inside the beaker at regular intervals. Okay, and we have to continuously stir it. Now we will obtain a graph between, that is the temperature readings in Celsius and time in minutes, which will be something like this. It's a very interesting graph, particularly these portions, these flat portions, that is OA, BC. These are very interesting. So let us try to understand it from the start. Let's say initially ice is at a temperature of minus 20, okay, minus 20 degrees Celsius, when it is placed inside the beaker and is heated on a constant heat source. Now as you can see, when heat is supplied, the temperature, it rises, which is denoted, let's call this portion as OAC, let's call that point E, okay, E. So this EO portion, it denotes the rise in temperature from minus 20 up to 0 degrees Celsius. So from minus 20 to 0 degrees Celsius, there is a rise in temperature. Now something interesting happens when we reach point O, that is 0 degrees Celsius. The temperature remains constant, flat, up to point A. So here a concept comes which is called as latent heat, okay, which we'll discuss in a separate video in detail. So for now you just understand in a basic way that this latent heat, which is also called as latent heat of fusion, which applies both ways, that is for change of state from solid to liquid, that is ice to water, and also during the reverse process, that is water to ice, that is both melting and freezing. It applies both ways. So here this heat is used up in converting ice into water, okay, during the melting process, and water to ice during the freezing process, okay. And as it gets, that heat is used up in conversion of states, so it does not contribute to a rise in temperature, because conventionally if we supply heat to a substance, heat energy, there will be a rise in temperature. But here this heat is used up in changing the state of a substance from one state, completely from one state into another, okay. So this is called as latent heat, and latent means hidden. So this heat is hidden, okay, like that. So we'll discuss about it in detail in a separate video. For now you just understand in a quick way this, okay. So it happens, so when all of the ice, okay, when all of the ice is completely melted, we get liquid water at 0 degrees Celsius. This is solid ice at 0 degrees Celsius, okay, solid ice. This is liquid water at 0 degree Celsius, okay. So liquid water at 0 degree Celsius, all of the solid ice has been converted into water, okay. All of the solid ice has been converted into water. Now the important thing to understand is that as long as there will be some ice left, okay, this temperature will not fluctuate, it will remain constant. This state particularly, once there is water and there is ice also, in this state where there is a mix of both the states, that is solid and liquid, in that condition the temperature will not increase. The temperature will remain constant, that is, the latent heat, it will, it will get used up in converting in the entire solid ice into liquid water, okay, that. So from A, when the liquid water is heated, okay, it slowly gets converted into water vapor. But this also happens in the same way. First, when the liquid water is heated, the temperature, it starts increasing until point B, okay, point B, which is 100 degree Celsius, okay. This is called as the boiling point of liquid water, and this is called as 0 degree Celsius, that is called as the melting point of ice at standard atmospheric pressure, standard conditions. Now when the temperature rises and increases up to 100 degrees Celsius, beyond 100 degrees Celsius, up after this point B, it remains constant, similar to OA, okay, it remains constant, flat, it does not increase. So in this portion, okay, in this portion, the heat is getting used up in converting the liquid water into vapor, okay, liquid water into vapor state. So in the portion BC, the heat is getting used up in converting the liquid water into water vapor. So this is called as also latent heat, but this is called as latent heat of vaporization, okay, this. So this applies both ways, that is water to vapor, that is liquid water to vapor state, and also vapor to water, that is vaporization and condensation. Both ways it is applicable. So when the process is reversed, that is, vapor is converted into liquid state through cooling, in that condition also this temperature will remain constant as long as the entire vapor has been converted into water. In this condition, this temperature it remains constant at 100 degrees Celsius as long as the entire liquid, okay, the entire liquid is converted into vapor. Nothing, no liquid is left behind. So as long as there is any liquid left behind, the temperature will not change. It will not fluctuate. It will remain constant. Similar to latent heat of fusion. As long as there is any solid ice left, the temperature will remain constant. As long as the entire solid ice is converted into liquid water, it will remain constant. When the entire thing has been converted, entire complete change of state, then the temperature will start increasing. Here also, when the complete change of state from liquid to vapor has been, it has happened, only then the vapor, that it will increase in temperature. Okay, so this is the basic concept of change of state from one state into another. Here we studied change of state from ice to liquid water, taking into consideration the latent heat of fusion. And again I repeat, this is applicable both ways, that is from ice to water through heating and water to ice through cooling. So if we reverse this process also, it will follow the same direction. Okay, OAB BAO, it will take the same path. If we reverse the process water to ice, then when the cooling happens, until point A there will be drop in temperature. When it reaches point A, as long as the entire water has been converted into ice, this temperature will remain constant, and only then it will, when it reaches O, it will start dropping. Similarly, when vapor is converted into water through cooling, that is condensation, this drop in temperature will happen from D to C until point C. Then it will remain constant as long as the entire vapor has been converted into liquid water. That is, from point B it will again start to drop. Okay, this. So here again, this is the whole concept, and here at this constant temperature points, okay, at this constant temperature points, here during this latent heat of fusion in this state in OA, both solid ice and liquid water, they can simultaneously coexist in thermal equilibrium with each other. Okay, coexist both these states in thermal equilibrium. Similarly, in this BC vaporization, latent heat of vaporization, portion, liquid water and water vapor, they can simultaneously coexist in thermal equilibrium with each other during this portion. Okay, so these are some of the basic concepts. Now the important points in the curve, which is the melting point, which is the temperature at which the solid and liquid states of a substance, they coexist in thermal equilibrium with each other. So that is this point OA, which is denoted by temperature 0 degree Celsius. That is the melting point, because here solid ice and liquid water, they both exist in thermal equilibrium with each other and they coexist together. That is called as the melting point, the definition of melting point. So it is a characteristic of the substance, but it is dependent on the pressure. So we'll discuss how pressure affects the melting point and also the boiling point. Okay, so the melting point of a substance at standard atmospheric pressure, that is called as the normal melting point. Then boiling point. So This is the temperature at which the liquid and vapor state of a substance can simultaneously coexist in thermal equilibrium with each other. In this case, it is 100 degrees Celsius at this point. Okay, so here we have liquid water, okay, and water vapor, which simultaneously coexist in thermal equilibrium with each other. Again, it is a characteristic of the substance but is dependent on pressure also. Okay, so the boiling point of a substance at standard atmospheric pressure, that is called as the normal boiling point. So here we have discussed some change of states, that is from solid to liquid, melting, liquid to vapor, vaporization, freezing, that is liquid to solid, condensation, vapor to liquid. There is another change of state also, okay, in which the solid on heating, when heat is supplied, it gets directly converted into vapor bypassing the liquid state. So that is called as sublimation. Okay, so this process of transition of a substance from solid state directly to the vapor state without passing through the liquid state, that is called as sublimation, and the substance is said to sublime. Okay, so the examples of such substances are dry ice, which is solid, carbon dioxide, iodine, naphthalene, camphor. So these are some of the substances which undergo sublimation when heated. Okay, and in the sublimation process, the solid and vapor states, they simultaneously coexist in thermal equilibrium with each other. Okay, so these are some of the basic concepts related to change of states, particularly taking the example of melting of ice, heating of ice in a beaker, where it goes through the different states, melting, vaporization, and also taking the reverse case also, freezing and condensation. Okay, so I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to engineering, science and technology. Have a great day. Thank you very much.